So, let's take a look at the Insight program. Because the Insight system was developed in a working laboratory, one of the most important goals has been to make it easy to learn and easy to use so that students and collaborators can be as productive as possible. With this in mind, the top-level menu is designed to be used in the order in which an experiment is usually done. Thus, we start with setting up to do the experiment in Setup, where there are options to make adjustments to the camera or how images will be saved, and to create a new standard curve and to select different filters and wavelengths. As a general rule, however, changes to these menu items don't have to be made on a day-to-day basis unless different members of the lab are measuring different dyes or using different fluorescent substances. The next step is to take a look at the cells in Video Preview and then to proceed to actually doing the experiment. After the experiment is done, there's an option to re-ratio the images. While this option is not often used for experiments with cells that you're familiar working with, there are, of course, always some occasions when you may want to change the parameters under which the ratioing was done. Much of the time, however, you'll proceed either to the Measurements menu in order to review and analyze the graphical results that were generated in real time during the experiment, or will proceed to the Utilities menu, where you can play back the experiment as an animation, or add pseudocolor to the images in order to facilitate visual comparison of changes in calcium concentrations, or create an annotated montage of the images for your lab notebook or for presentation or publication. Okay, let's do an experiment. When doing an experiment, the first thing we do is to take a look at the cells by going to Video Preview from the top-level menu. Video Preview serves two main purposes: to allow us to find the field of cells we want to do the experiment on, and to allow us to adjust the brightness of the cells on the monitor. We've already identified a field of cells here, so the next thing is to adjust the brightness if necessary. One way to do this is by adjusting the intensity of the light source. The Insight lamp has a lever which allows us to continuously adjust the intensity, and in fact, this has already been done here. However, we can also change the brightness of the cells by adjusting the exposure time of the camera. Thus, for example, if I increase the exposure time from 20 milliseconds where it is now to 30 or 40 milliseconds, the cells appear brighter. If I had cells that were very light sensitive, I could now reduce the lamp intensity to minimize the amount of light they were being exposed to. For now, however, I'll go back to the 20 millisecond exposure time. Notice next that the time can be independently adjusted for each of three wavelengths, 340, 380, and 470 nanometers. The first two of these are the two excitation wavelengths of Fura 2 that permit us to do the ratiometric analysis of intracellular calcium. These cells appear somewhat different at 340 than they do at 380, having less distinct nuclear fluorescence and requiring a longer exposure time of 30 milliseconds in order to be as bright. The third wavelength is for observing the cells for some other fluorescent characteristic. For instance, if cells have been transfected with a green fluorescent tagged gene, the expression of that gene can be detected at an excitation wavelength of 470 nanometers. And if we switch to that wavelength, we do indeed find two cells that are brightly fluorescent at 470. We'll see how this can be useful in the experiment in just a moment. So, we've found our field of cells, and we've selected a lamp intensity and camera exposure times, and we accept these conditions and go on to the next item from the top-level menu, Experiment, and select New Experiment from the drop-down menu. In keeping with the Insight principle of making things as easy and intuitive as possible, the new dialog box that opens up is organized in a top-down manner in the order in which an experiment should be done. The video preview is the exact same as that which we just used in the top-level menu and is reproduced here because it's sometimes convenient to use it without having to leave this dialog box. The next step, after selecting the cells and the brightness, is to get a background, and so this is the next item down. Since other steps which follow should not be done before capturing a background, they are temporarily grayed out. When we select Capture Background, we're reminded to select an area which does not contain cells, and after we click OK, and the program gets backgrounds at each wavelength, we're reminded to refocus the image on the cells. Now we're ready to select the cells we want to measure. Let's select the GFP positive cells first by using the 470 nanometer image and clicking on Define Objects. This takes us to a new dialog box where we see again that two cells are GFP positive. Since they are irregularly shaped cells, we select freehand rather than circle or rectangle as the method for defining each cell. I click once to start drawing and click a second time to complete the object. I do this for the second cell as well. Now I'm finished with the GFP positive cells, so I select Continue to return to the experiment dialog box. In order to select other GFP negative cells, I can select either the 340 or the 380 nanometer wavelength and click again on Define Objects. But now all of the cells are visible because all of them have been loaded with Fura 2. I'll just outline 3 cells for this demo. Notice that for one of them I included a region that clearly represents the background rather than the cell. In order to teach the program what background is, I now click on Test Ratio, that when you have small fluorescent values that have escaped background subtraction due to camera dark noise, you tend to get either very large or very small ratios, which are then mathematically converted to either very high or zero calcium concentrations. In order to get rid of this background artifact, I increase the threshold that a signal must be above background in order to be seen as a real value from 0 to 10 gray levels. This is out of a total of 4,096 gray levels available, and I click again on Test Ratio. This improves things considerably, but going to 15 gray levels and doing another test ratio improves them even more without affecting the real signals from the cell. Notice that now the GFP positive cells are shown in green while the GFP negative cells are in red. Okay, now I'm done identifying the objects of interest and selecting a threshold. I'll click on Continue again to return to the experiment dialog box. Now we're almost ready to start the experiment as soon as I give it a file name. Let's call it EG for my initials, underscore fibroblasts underscore bradykinin for the agonist that I'll use, and we'll save this. And now I'll start the experiment. Once I add the agonist, I can mark the event. And once the experiment is done, I can click on End Experiment, and I'm ready to go on to the utility functions in the program.